In this video, we're going to talk about limits and how to find them. A limit is a value that a function takes on or approaches. It is found similar to finding the value of a function at a given input, but it doesn't mean the same thing. So for example, in this case, we have two y values that correspond to the same x, but one is excluded from the domain and one is included. So the function here is defined at this point for this particular y value. But the limit of the function, since the function goes through this point here, will be taking on at this particular y value. So at 1, the limit will be defined by this non-filled in point, but the function itself will be defined by this filled in point. Let's see what it looks like algebraically. Consider the following function, 2x squared minus 4. We want to determine the limit the function takes on as x approaches 3. So, in order for us to find the limit as x approaches 3, all we need to do is substitute the value of 3 in for x in the function equation and evaluate it. So this equals to 2 times 3 squared minus 4. So therefore, the limit of 2x minus 4 as x approaches 3 is equal to 2 times 9, which is 18, minus 4, 14. What does it mean in terms of the graph? This is a quadratic function, 2x squared minus 4. The vertex is shifted down 4, parabola opens up, and it has a vertical stretch of 2. So, when x is 3, the limit the function takes on is 14. The function is continuous, so the function is also defined at this point. So the limit corresponds to f of x. It corresponds to the defined value of the function at a particular x. Sometimes it's not that simple, and it's important to look at the type of the function that you're dealing with before you try to determine the limit. For example, if I try to find the limit of 3 over 2x plus 1 as x approaches negative 1 over 2. If I try subbing in the value of x into this function as is, I'm going to end up with 3 over negative 1 plus 1, which is 3 over 0. It's undefined. Why is that? Because this is a rational function, and in a rational function, I need to be very acutely aware of the restrictions on the denominator. Since I cannot simplify this function further, I cannot factor anything or expand or anything like that. It means to me that because there is a vertical asymptote at x equals negative 1 over 2, the limit will not exist because the function approaches the asymptote, but it never touches it. It's never defined on the asymptote. It's an infinite discontinuity. The function has no limit at that particular x value. as x approaches -1/2 equals d n e does not exist. Let's try to determine the limit of the following rational function as x approaches 2. So we've already seen that it makes sense to try and simplify the function first before subbing in the value. So let's simplify x squared minus 4 over x minus 2. I can factor the numerator. This is a difference of squares, so it turns into x minus 2 times x plus 2 over x minus 2. I can clearly see that there are two identical factors that can be reduced, x minus 2 and x minus 2. They are eliminated completely. So I can see that there is a hole at this point. When two factors reduce completely in the numerator and denominator, it creates a hole in the function. And the simplified equation of this function is f of x equals x plus 2, and there is a hole at x equals positive 2. Now, in order to find the limit, I'm going to use the simplified equation. Let's try that. Limit of the original function as x approaches 2 is defined by the new equation of the simplified function x plus 2. And if I sub in the value of 2, it becomes 2 plus 2. So therefore, limit as x approaches 2 of x squared minus 4 over x minus 2 equals 4. What does it mean graphically? So the graph of this function in its simplified form is x plus 2, the y-intercept of 2, and the slope of 1. It's a straight line. And then when x takes on the value of 2, the corresponding y value is positive 4. The limit exists, but the function is undefined at that point. It's a hole, non-filled in or blank circle. So the function is undefined at this point, but the limit exists. When x is 2, or when function approaches the value of x of 2, the value of corresponding y or output it approaches is 4.